I see cloud more as a part of an overall strategy that includes legacy applications as well as cloud applications deployed on private clouds as well as public cloud or hosted private cloud implementations. So it's really all about interoperability and networking and integrated cross-domain management. All right, I'll move quickly. I'm Joe Weinman. On Twitter, I'm Joe Weinman, and actually wasn't playing around there. I was tweeting the conference as I have been for the last 48 hours or so. Briefly, those of you that don't know, Telx is a carrier-neutral cloud enablement, co-location, interconnection hub firm, and we sort of hook all of these different entities together. That's just by way of intro. So I'll jump right into a few thoughts related to cloud, which are not all directly standards related, but what I want to do is first talk a little bit about cloud strategy, then I'm going to touch upon some cloud mathematics and economics, then from there I'm going to talk about implications for standards. So the first observation is, the question you could ask is the cloud strategic? And that in turn leads you to a more basic question, which is IT strategic? There's a thought out there in a famous book called IT Doesn't Matter that suggests that because IT is ubiquitous, it's therefore a commodity. If it's a commodity, it can't be strategic. To put it bluntly, I couldn't disagree more with that analysis, if we can call it an analysis. And briefly, what I would say is, can IT be used for fairly boring tasks like room reservation systems? Absolutely, but I think that IT can be strategic, and the cloud specifically can be. So to answer that, my observation would be to use the Tracy and Wiersma framework regarding what is strategic, and basically what they say is, for any business to achieve competitive advantage, you can focus on either having better products, or what they call product leadership, better processes, or what they call operational excellence, or better relationships with customers, or what they refer to as customer intimacy. Now, all that said, there's a fourth thing which they didn't include, which is innovation, which I see as key. I did a Forbes post on this a couple of weeks ago, so I won't go into depth on it, but briefly, when we think about better products, not only IT products, like let's say tablet computer, or enabled by cloud services and differentiated by their application ecosystem in terms of stores and downloads, but also functionality like Siri running in the cloud, or other applications like collaboration, synchronization, markets, etc. So the cloud is relevant there. For processes, the cloud can certainly help enable a variety of processes to achieve operational excellence, and I would include things like field delivery or field support, where, for example, logistics trucks can do optimized routing based on real-time data uploaded from the mobile cloud, and route optimization using calculations performed in a scalable cloud infrastructure against big data. For relationships, I would just point to Amazon or Netflix or Pandora, where it's not looking just at your own pattern of usage, but actually knows more than you do about what you're likely to enjoy, based on being able to do, again, big data analytics around essentially cloud-enabled data. And then lastly, in terms of innovation, things like contests, for example, the Netflix Prize, or you could look at Goldcorp or Harrah's doing data mining around casino play. And in effect, the conclusion you come to is that across all these four areas, not just IT, but the cloud is strategic. So if it's strategic, one of the things that we'd like to look at is some definitions of the cloud and also what they imply mathematically. So Chris Kemp put up the NIST definition. The NIST definition is a great one. Now I think settled down in version 15, so Don's team has been working on that. I have a much simpler definition, which is actually a handy, memorable mnemonic for those of you that are English speakers, which is that a cloud is a common location-independent online utility on-demand service. And so common, of course, means aggregated demand served out of a shared pool of resources. Location-independent implies ubiquity, as well as not no need for transparency, but moreover the notion that you can service your transactions within a response time envelope that is application dependent and context sensitive. It's online in terms of the network being critically important. You can't be untethered for the cloud to work. It's a utility in terms of what might be called usage sensitive pricing, pay per use, measured service, linear tariffs, whatever term you'd want, and it's on demand in terms of the right resources are available at the right time. Now, it turns out that all of those criteria are not just a clever mnemonic restatement of the NIST criteria, but all have easy to characterize mathematical properties. So in terms of commonality, if we aggregate independent workloads, there's a relative penalty function that can be defined in terms of undercapacity or overcapacity. And when you look at that, you end up with a 1 over the square root of m effect, where m is the number of independent random variables, aka workloads or customers. So in the limit, if you have an infinite number of workloads, the penalty function goes down to 0 because you get perfect smoothing, therefore perfect utilization, therefore optimized economics. The much ballyhooed economies of scale turns out to be irrelevant because you don't need for there to be economies of scale to achieve these statistics of scale phenomena. In terms of location independence, you also end up with a 1 over square root of n effect on a plane, which has to do with the fact that for a fixed radius, assuming that distance is a proxy for latency, which it isn't always in routed networks, but is close enough for our purposes, you end up with a 1 over square root of n, which is unfortunate because it means that early latency reduction you can get at high degrees of efficiency. You know, for example, on the planet Earth, you go from 1 node to 2 nodes and can reduce latency from 160 milliseconds to 80 milliseconds. But at some point, of course, if you have 1,000 or 5,000 nodes, the next trillion nodes or the next 100 billion trillion nodes only give you less than a millisecond worth of latency reduction. In terms of online, we won't get into that, but you can look at a variety of trade-offs in terms of point-to-point versus hub-based networks and everything in between. When you do that analysis, you can characterize a latency penalty in hub networks of 47% based on the expected distance of 2 random points on a unit circle versus going through the hub. In terms of utility pricing, it's relatively easy to show that if a demand is relatively spiky, then even a very expensive utility with a high premium expressed as a ratio is actually less expensive than do-it-yourself. And that's why people rent cars, even though they pay $50 a day for the rental car versus $10 a day would be the attributed cost for your own car. And in terms of on-demand resources, you end up with a variety of different characteristics based on the demand function. So if you assume linear demand and a fixed provisioning interval, the penalty is linear. If you assume exponential demand and a fixed provisioning interval, you actually end up with an exponential penalty. And if you end up with a random walk, Einstein showed that you end up with a square root of n function there in terms of expected translation distance, and therefore what happens is that you have a sublinear benefit to time compression. In effect, because the distance flattens out because of that square root of n effect, that time compression actually reduces the flat portion of the curve, not the deeper portion. If you're interested in these, each of these formulas is about a 30 to 82 page paper. That's all at joeweinman.com/papers.htm. Got a 420 page book coming out in 2 months that goes into a lot more depth on this. But the point is that rather than throwing out terms like, you know, public cloud is better, private cloud is better, whatever, we can express it mathematically. In fact, some of you know you can express it axiomatically from the foundations of set theory, measure spaces, metric spaces, function spaces, and vector spaces, and get all this cool stuff going on, and you can characterize them, these benefits. So to go to the fourth one around utility, the other interesting thing is that basically for any curve, except for a few pathological ones, a hybrid cloud is optimal, and that's subject to some considerations like network costs. Obviously, if you need a fixed cost network that costs $20 million, it's not going to pay you very much to save a nickel on a virtual server versus do it yourself. So it's combinations of network utilization profiles, application profiles, et cetera. But that then leads you, if you get into hybrid architectures, then you end up with this notion, of course, of hybrids and the intercloud. So it's kind of a mathematical foundation for a lot of the structural architectural concepts we've been talking about. I don't have time to go into each of these. I'll just point out that you can look at sort of a variety of different characteristics ranging from infrastructure, including data network, up through process, and not just as a service models, but a variety of other characteristics, including looks like it was cut off a little bit, but sort of legacy IT approaches through private cloud, through public cloud, through hosted private cloud, right, where you've got dedicated resources at a fixed rate per time period, but they're located somewhere else. And that in turn leads you to all of these different variations. I don't believe, and I believe that I've proven beyond the shadow of a doubt, that all IT will not move to the public cloud, not only due to economic considerations such as switching, migration, information, and transaction costs, but also based on looking at the cost structure of the scale-out model of the cloud and the notion that SG&A is likely to trump benefits due to quote-unquote economies of scale. You don't have to be very large, back to the 1 over square root of n effect, to get pretty good reduction in the penalty function of over or under capacity, which means that actually if you have a sufficiently diversified enterprise, and I think General Electric is an example of that, with basically independent workloads from different BUs, you can do your own stat muxing and achieve your own economies of scale, and therefore operate at pretty close to the cost point that's relevant. And that's before we get into other characteristics. For example, if you look at Zynga, they were using Amazon. They just brought things in-house. By going to a custom-tuned architecture, they actually require 1/3 the resources, even though they're using the same stack and the same application architecture as what runs at Amazon. So for all these reasons, I think we've got hybrids, because we have hybrids, and also because you don't have to be very large to achieve the right economic cost points, and therefore can compete on other things like customer intimacy, like proximity, et cetera. You're not going to have just 5 big providers any more than you just have 5 retailers. Does Walmart have a significant amount of industry consolidation or concentration effects at its disposal? Yes, but there's also mom and pop corner groceries and delis, so there's actually a very fragmented market, whether you look at retail, telecoms, hotel chains, et cetera. So therefore, because you have lots of providers and because you have sound economic analysis that I think clearly proves the inevitability of all those providers, it just underscores the importance of a variety of different both intercloud and other relationships in terms of all of these intermediaries here. We're seeing lots of interesting things arise. For example, Strategic Blue is a broker-dealer that transforms the financial payment stream from a consumer into what a provider requests. There's all sorts of cloud service brokers, intermediaries, Expedia equivalents, et cetera. So with that, I think I better shut up before I even further overstay my welcome. And I did it in 6 minutes or so, give or take. Okay.